So guys, let's start our class. Today there are our topics. Actually, you already covered some of them previous time. Like matrices. In spite of it, let's go briefly because it's important. Who can explain what does it mean, matrix? Yeah. Let's start from less, how to say, complicated stuff. And could you speak louder? Okay, cool.
A set of number organized into a rectangle.
Okay, anything else?
It's a lazy way to introduce couples of equations.
Okay, nice. What else? Yes.
It's an array of arrays of integers.
Okay, only numbers, or it can contain something else?
I thought about this too. Probably something else.
Okay.
Well, maybe other matrices.
It might be, but actually, yes. Okay, what else? Guys, if I ask this question in such manner, so what also can be a matrix? Okay, so yes, it's a great film, but not only.
It's our life.
Before this, our objective for today, to understand what is it, how it can be used, and how to find it. As usual, nothing special, because you need to understand why we are studying them. Okay, we are opening math, not matprofi, but matprofi in Russian. I forgot how it's called in English, this site, and we can read that it's a rectangular array. Some of you already said that rectangular lazy ways yes, about equations you agree, because expressions. If you put a lot of expressions in one matrix, it's a couple of linear equations. Symbols, numbers, and so on. How we are defining the matrix size, we already discussed it. So, this matrix A, B, C will be 3 by 1. So, 3 rows and 1 column. Everything is clear. Okay. About operations. We also covered this, but I'd like to ask, what does it mean, trace? Who can explain? Давай.
It is some.
Louder.
It is some of our variables of matrix.
Who get what he said?
Yeah.
So, okay, could you say what will be the trace of this matrix?
It will be 15, and the trace is the sum of the elements of the main diagonal.
Sum of elements on the main diagonal.
Nice.
А что?
Okay, why do we need it?
No reason.
Just for fun.
Just for fun?
Oh,
Okay.
yeah.
Team, what do you think?
We didn't yet discuss what do we need matrices for, so it's strange to discuss what we need traces of matrices for.
Why do we need matrices?
Yes.
Why do we need matrices? Probably for fun.
Yeah.
That's
what.
What can I do today? I can either play, I don't know, computer games, I cannot know, programming. Oh, okay, guys, I'd like. Oh, nice. 5. Oh, hooray, nice, yeah, nice. Besides this, okay, besides this, matrices is our formula.
If we make equivalent matrix, it will have another trace.
What do you mean by equivalent matrix?
Every matrix can be represented as digit 1 in the main diagonal and zeros in
Triangular.
No.
Triangular.
Identity.
You're talking about identity matrix?
no.
Or you're talking about when we have some matrix like
If we do some operations with this
yes, and
matrix,
after
we
this
can
we'll
get
receive 1 1 and something there. I mean 5 for instance.
What is that? It's not a matrix.
and zero.
Triangular
for
matrix.
example.
Okay.
Yes.
Triangular matrix.
No.
You heard about this one?
No.
No? So I didn't get the question then.
Afterwards.
Okay. So, about operations. Summarization, multiplication, order is important. Again, no division because we have inverse matrix instead of this. Multiplication, scalar, transpose. About transpose. It will be
What's inverse?
inverse matrix.
Yes.
It will be probably on next class. We won't use it today.
Okay, we'll use something
Usual
from
matrix
here.
multiplied by inverse matrix do nothing.
Equal to identity matrix.
Okay.
Okay, roughly speaking, just okay, because we have a very curious guy. The problem is that because we have some order, we cannot say that, and you may see we don't have division. So, A, for instance, B equal to C, if I want to find
Can we
B.
write that dot?
Okay, if we want to find C, we cannot say that, or if we want to find B, we cannot say that B equal to C divided by A. It's wrong. But we can say that A minus 1 A B equal A minus 1 C. And after this equal to identity,
Oh.
and B equal to A minus 1 C.
Wow.
Inverse matrix. Cool. This is inverse matrix. How to find this? It's not certain. I just answering what is it and why do we need it. Who didn't get how to multiply matrices? Raise your hand, please. I like you didn't get how to multiply. Who can explain? Okay. Можешь объяснить? Yes. Could you explain it on the whiteboard? So you have this task and just to solve it, explain to him. You should explain him and we have an example. You can do this, the case study. Yes. Тебе?
Desk is.
И то есть это не то.
Yeah.
I can be stupid. So, we have one matrix and another matrix. We do multiplication. First of all, we should
Could you not use cross because we have cross product?
You wrote cross multiplication.
Matrix cross matrix.
Still no. That's a dot product. Just no sign. Just no sign. Yeah.
You know, cross and dot product are not defined for such matrices. So only for square matrices.
Could you explain to the audience, not to the whiteboard?
We
There is
can
dot here.
do multiplication because we have 3 here and 3 here. Got it?
Guys, they're
Yes.
asking you.
Yes. Cool. Okay. Why we do that? Because we work with that and with that thing. It looks fine. with another. You got it? This, and this.
Alec, did you get? Because they explained to you. No, guy, don't be shy. Actually, it's not because two people from the previous group didn't remember how to do it, and it wasn't. So, okay, could you say how to find the last row, last column, A22? I mean, okay, could you explain which row and which column we are using for this one?
The last row of the first matrix and the first column of the second.
Okay. So, thanks.
Apologies.
About transpose. There are different ways how to explain this. Actually, we have formal definition there. You can think in terms of we have the main diagonal should be the same, and we just swap numbers. So we have there we have 2 4. We have 4 2 because it's a rectangular matrix. We put 3 there and 6 there. So who can explain in different manner? How are you understanding transpose?
Rows become columns and columns become
Okay, the easy way. So nothing special. I hope you won't make a mistake. Why do we need it? I explained you that using transpose we can represent our dot product as a x transpose y. And we won't have a lot of we won't. One of the main problems we will face it on the second task, where it can be used in mechanics, circuits, economics. So we just when we need a dot product, we can represent it as this format. Okay. Who wants to solve B and C? One of guys should solve B, another C.
It's not a homework.
No. Давай. You are going the C.
Was it not for the previous lab?
I took it by myself. It's not. I don't remember actually.
Okay, if this is from file lab 3 PDF at Moodle.
Yes.
And today is lab 4.
No.
No?
Okay. Before this class, Ivanov said why we have different notations between labs and weeks.
Do we?
Today, actually, today, and as you may see, my lab also called lab 3 because we have 0 lab, first, second, third in my notation. In the weeks we also have, but actually it's 4th week because the next week we will have a test. Yes. So you also think C? Who want to solve VP? Okay.
On which in 7th?
But actually you're too smart. Could you go? Yes. No. Him, yes.
It seemed like you were pushing him away because he is too
Yeah,
smart.
because he answered on all questions. I'd like to see other guys from this class.
Yeah, we get it. You just didn't kind of distinguish between the two guys. Second one phrase, yeah.
What's your name? Yeah, B, yeah. Okay. I need to prepare answers.
I thought it was our homework. I was rushing it today morning.
3, 1, 5 minus 2.
Nice way of preparing answers.
Again, if you want to check how you are calculating, just do like me and no problems. So be easy. Of course, I'm talking about home tasks, not about exams or whatever.
I?
I, it's in the matrix.
Well, like
5, then 4, 3.
Okay, we have all answers.
Don't look at that. Do not look at that. Yes, I can see it.
Guys, try to do it at home. I mean, there, if you didn't do it at home. By the way, who tried to solve this lab? Okay, I see. Okay.
I thought you should like solve the lab 3 homework,
Damn.
but it is like
Okay,
I
guys,
solved
I
it.
see this. I understood that most of you didn't get. So, before the class, you try to understand what's going on in the lab.
okay.
So you need to look at this, try to understand how to solve this. And after the lab, you are solving home task.
Whoa.
So
I think that's homework from previous lab.
So there is a PDF. There is first part with
yeah, try. So how is your? I'd like to say that something is going on wrong there. 3, 1, 5. Why are you solving first? I said you solve B. Just I able to get. What are you trying to solve? Are you trying to solve B? Okay, so 2a minus 3b plus y. Okay.
So the part before keyword homework in the PDF should be solved when?
Before the lab.
Before the lab. Then what is lab for?
First of all, to understand what's going on, probably I am giving you extra material. I hope you agree with it. I explained some concepts if you didn't get during the lecture, how to solve this. So after the lecture, it's the reason why we have the gap. We specially made it because you had lecture, you have tutorial, you have some theoretical knowledge. You are trying to apply it on the Monday's lab. So you already have Monday lab till Monday. I mean before Monday. You try to do it. You understood something. You know how to do something. And after this, yes. Okay, 15 minus 1, 1. Yeah, nice. Okay. Minus 1 minus 4, 29 minus 5. You have mistake. Last row, last column. BA. BA. And there too.
You can solve 5 minus 8.
You have both mistakes in last column, last row.
Right, just write
Minus 3.
yeah.
Yes, and in the BA you also have
3
mistake.
minus 12 it must be minus 8.
And there have
3 minus 8 probably.
I mean like 3 minus 8.
Not minus 12 but minus
Because
8.
it's minus
3 minus 8.
4.
Yes. Please pick one of instead of 12, 8.
So to sum up, some bad TAs can put you 0 for this for not this task, for other task, because you made so you solved it incorrectly. And the second, okay, I don't want to check the whole solution. The answer is wrong, 0. So I mean, try to not make such silly mistakes. It can drastically decrease your score.
Try to not make mistakes. Makes sense.
I know. Okay, let's go to this task.
Let's.
Right now.
By the way, is it true that matrix multiplication is associated?
Yes.
Okay, go stop. Okay, so ABC.
No.
What no?
No, it doesn't.
Okay. Could you explain why?
Because okay, yeah.
Me?
Yeah.
On A matrix we have 3 by 3, right? On B we have 2 by 3. The error is 3 by 3.
Yeah. We cannot eliminate them, so it's wrong. Okay. A, B transpose, C transpose.
Yes.
Okay. Because in this case it will be 3 by 3, 2 by 3, 3 by 2, bam bam.
3 by 2 in B.
No.
B will be 3 by 2
Yeah,
because
it will be
transpose.
3 by 2 and 2 by. This one is 2. That one is 2. That was the last. Okay.
3 by 3.
Yes.
3 by 3, 3 by 2, 2 by 3. No. Oh yeah.
Oh yeah.
Okay, Ебай.
Чё?
What?
What? That you are
Why?
Okay, guys, I made this task 2 years ago.
Why do we need these? Anyway, 2 times, but we do not need.
You know,
What do you think about this?
I've been reading about scholars.
Guys. I'm listening question. I think I need to check.
So
No, it doesn't. 1, 2, 2.
it doesn't exist.
Yeah, it doesn't do because E is 1 of 3 and then. Yeah, okay. And the last one, the most interesting one. Timothy, what do you think?
Right, first we write 1 multiplied by 3, 1, 3.
Is it evaluated left to right?
And this is 3, 2, and E 2, 1.
Actually, you are both Timothy's.
What?
You are both Timothy's.
And Коля too?
No, Timofey and your neighbor Timofey.
Okay.
Коля
I got it. I got it. Who can answer?
Actually, I'm asking others. Okay, you have a blue bracelet. You can call blue bracelet. Right?
You can call me Blue Timothy.
Blue Timothy. So, what do you think?
I think on D because on the right we have 1 by 1 dimension, and on the left we have vector, and we can multiply cross product vectors which have different dimensions.
So, do you want to say that cross product between 1 by
What's the first operation? Between cross product between 2 vectors, or
Is it vectors?
Yes.
no, transposed vectors?
No, the transposed are vectors. K is not a. K. Oh.
He transposes 1.
Yeah.
by
I
3.
thought you have written the mentions
Can we
before.
do like this or
transposed.
no?
No, probably no.
Why not?
Yes.
Probably we can.
We can.
Yeah, we can.
It's vectors too.
But
no.
like
No, we can't do.
Between these vectors, 0 angle, and when we cross product two vectors to coordinate vectors, we have 0.
First question, can we do like this? And the second, the operation order. If you how to say, as I explained, the problem with order that you can forget what should be first, what should be second, and so on. And it's the reason why we can represent in different manner to eliminate somehow this sign. What can we do? I explained in previous class.
Scars.
Q symmetric. In this case, I'm not actually. I will send you to the lab. I don't remember. Can we do 1 divided by 4? I mean,
No,
for
you
this
can't.
guy, we cannot make a square symmetric. So in this case,
I
even
mean-
more, we can. This operation is not defined.
Yes.
But even if it would be defined, I say so. I don't have proof to other way. Even in this 3 by 3 and y by 3,
3 by 1.
I mean no k transpose is also 1 divided by 3. We can. So this operation is not defining in any case.
Which operation?
Only for vectors. Look what you've written. 3 by 3
K transpose.
and no, I mean dimensions. 3 by 3 and 1 by 3. Why
Oh,
1
1 by 3. 1 by 3.
So should
down
be
there.
by both.
One.
K transpose is 1 by 3.
3 by 1
But
and
both
1
key.
by 3. If you don't use transpose.
What do numbers below mean?
The lowest numbers.
1, 3.
Which you crossed out. 3 by 3 and 1 by 3. What are they?
Using, I don't remember, but I told you, even we are consuming that we can make a skew, let's say, skew symmetric matrix. This operation we can transpose as K transpose like this. This matrix will be 3 by 3 because it's symmetric matrix. This one is 1 by 3 because K transpose is 1 by 3.
Oh, and you can't multiply.
And I cannot multiply them in any case. So I cannot say, can I do, I don't remember. It's the reason why I say I'm preparing it for you. I mean, I will send it to the group. In spite of it, knowing that I can run, as let's say, make the, in cross product I can the first operation make a symmetric matrix. I can understand that I cannot solve this task in any case. And let's assume that we have no transpose there, the common. It also helps me to understand that in this case I don't need to think what should be first. I mean, cross product or something else. I can just rewrite it in just multiplication and do it from left to right without any problems. So like this and C E transpose. Of course, unity operation is the first. I mean, we just let's say changing the and after this we just solve this. Everybody get what we did there? Could you see it in other place? You can see on the second row. If you cannot see, it's easier for me to guess.
Why don't we just multiply like the usual vectors when we get a vector?
Because they are row vectors, it's not vectors.
It's row. One.
Okay, if it's not row then.
It's not.
Yes.
It's not row. If it will be 3 by 1, we can.
Okay.
According to the definition, in cross product, cross product can be done only when we have two columns. I mean, two vectors 3 by 1. It's not defined in n space.
Who is going to give this line? Because it's defined like so.
Just cross product operation can be done on the 3 by 1 matrix multiplied by 3 by 1 matrix. Actually, if you'd like to understand how it appeared, I can give you, say, boom, I can blow your mind. Do you know what is it? Who have heard about quaternions?
What?
Quaternions.
What's the Russian for?
Quaternion. What the actually quaternion appeared before the vectors, historically. And quaternion is a plus by plus
It's not y.
c times j plus d.
We studied it in school, it's body shape.
So it's why do we need them? When we're talking about angles, we can define rotation using quaternions.
What is it?
We can say that vector is simplified version of
With a equal to
quaternions.
0?
And when you're making, what does it mean? EGK, it's
basis vectors.
No,
Then what
it's
is
complex numbers.
Ah,
And
Whatever. Actually, it's the same if we represent.
in this case, even with the exceeded version of vector, yes. But I mean that we can define cross product. We will divide two quaternions, and on natural part we will receive dot product, and on let's say imaginary part you will receive cross product. So you don't need to understand this. I just gave you one of the, let's say. So
what are J and K?
it's, let's say, it's just imaginary part.
And then
We have
what-
we have basis on imaginary, yes. area.
how we can have multiple dimensions in imaginary? Like it should be
Like you have second
real
dimension.
part
No,
dimension.
sorry, it's not. It's out
Third
of scope from
dimension
this
is
class.
the-
Okay.
Quaternions, actually, I don't know people, my neighbors who can understand quaternions on fingers. As for me, it's a good way. We have some singular values, singularities in our matrices. I will explain later when we consider about rotations.
Okay.
Because when we talk about rotations, I mean complex rotation in space, we can represent them using collinear angles or fixed angles, and you will have such singularities. Or we can represent them in quaternions. And when we are using quaternion, we can, we won't have any singularities. And common function in unity in this, you can work with quaternions. When you need to understand the silicon, you can just make other angles. Look at this. I mean, look how your figure rotate. Rotate was rotated right now. And after this, return to quaternions. That's it.
What is singularity?
Singularity, it's вырожденный случай in Russian. When you have some special cases when something is not working. Yes.
A is a vector, am I right?
Every K transpose, it's transpose vector, okay, it's like column. Or is it just one row?
Is it vector or not?
Everything is vector there.
No.
I mean,
No.
matrices or vectors. I didn't get your question.
K is a vector. K transposed is not a vector. It's a row vector, which is not a vector.
Wrong vector.
Yeah, it's a wrong vector.
Impulsor vector. Okay. Okay, about this task, yes.
So in this task we second. In this task we can
Second, this one or this one?
yes.
Yes.
So in this task we can say what A is a vector.
No.
No.
B is vector.
B is a vector.
Yes.
Okay, thank you.
So in this case, what will be this? What not?
AB won't, BA will. A transposed B will, BA transposed won't.
AB, we may say that yes, it will be 1 by 1. It's dot product actually. And BA is 3 by 3, outer product. These guys just not exist.
It's just multiplication, I don't see any reason to solve it. Okay, let's go to the determinant.
Hello again. So moving forward, I'll be assuming that you have a visual understanding of linear transformations and how they're represented with matrices, the way that I've been talking about in the last few videos. If you think about a couple of these linear transformations, you might notice how some of them seem to stretch space out, while others squish it on in. One thing that turns out to be pretty useful for understanding one of these transformations is to measure exactly how much it stretches or squishes things. More specifically, to measure the factor by which the area of a given region increases or decreases. For example, look at the matrix with columns 3, 0, and 0, 2. It scales I hat by a factor of 3 and scales j hat by a factor of 2. Now, if we focus our attention on the 1 by 1 square whose bottom sits on I hat and whose left side sits on j hat, after the transformation, this turns into a 2 by 3 rectangle. Since this region started out with area 1 and ended up with area 6, we can say the linear transformation has scaled its area by a factor of 6. Compare that to a shear, whose matrix has columns 1, 0 and 1, 1, meaning I hat stays in place and j hat moves over to 1, 1. that same unit square, determined by I hat and j hat, gets slanted and turned into a parallelogram. But the area of that parallelogram is still 1, since its base and height each continue to have length 1. So even though this transformation smushes things about, it seems to leave areas unchanged, at least in the case of that 1 unit square. Actually though, if you know how much the area of that one single unit square changes, it can tell you how the area of any possible region in space changes. For starters, notice that whatever happens to one square in the grid has to happen to any other square in the grid, no matter the size. This follows from the fact that grid lines remain parallel and evenly spaced. Then, any shape that's not a grid square can be approximated by grid squares pretty well, with arbitrarily good approximations if you use small enough grid squares. So, since the areas of all those tiny grid squares are being scaled by some single amount, the area of the blob as a whole will also be scaled by that same single amount. This very special scaling factor, the factor by which a linear transformation changes any area, is called the determinant of that transformation. I'll show how to compute the determinant of a transformation using its matrix later on in this video, but understanding what it represents is, trust me, much more important than the computation. For example, the determinant of a transformation would be 3 if that transformation increases the area of a region by a factor of 3. The determinant of a transformation would be 1/2 if it squishes down all areas by a factor of 1/2. And the determinant of a 2D transformation is 0 if it squishes all of space onto a line, or even onto a single point, since then the...
What can you say about this matrix?
It's linearly dependent.
Yes. Do you remember that when we solved about some... So actually, as I told you before, that when we have some matrix and we can some vectors and we can represent them as n by n matrix, we can easily understand is it linear dependent or not, just using determinant. When we calculate determinant, if we have equal to 0 in this case, we can surely say that this matrix have some have some dependent values, like there. That
is it two-way? Like determinant equals 0 means that, and it's meant by that a matrix is linearly dependent.
Linear dependent, yes.
The question was about it does work in both ways.
Why it works?
What?
If you have a square matrix, it works. It works. Even more, how it's actually it's explained on this video. We have rank of 2. We have two-dimensional area R2. So just plane. When we have 0, it means that we have low dimension. Actual line, it's one-dimensional space. Or when we are talking about 3D, what?
Which 0?
This 0.
This 0. Okay.
The area of any...
When we have 3 by 3, we are talking about space. If we have some, if we have lesser, equal to 0, it means that at least it will be a plane. Because in each 3D, when we have two linear dependent, vectors, and we know that their dot product equal to 0, so in this case, each two vectors, they are linear dependent, will provide you a plane.
But for now, I just want to link to a line, or even onto a single point, since then the area of any region would become 0. That last example will prove to be pretty important. It means that checking if the determinant of a given matrix is 0 will give a way of computing whether or not the transformation associated with that matrix squishes everything into a smaller dimension. You'll see in the next few videos why this is even a useful thing to think about, but for now I just want to lay down all of the visual intuition, which in and of itself is a beautiful thing to think about. Okay, I need to confess that what I've said so far is not quite right. The full concept of the determinant allows for negative values, but what would the idea of scaling an area by a negative amount even mean? This has to do with the idea of orientation. For example, notice how this transformation gives the sensation of flipping space over. If you were thinking of 2D space as a sheet of paper, a transformation like that one seems to turn over that sheet onto the other side. Any transformations that do this are said to invert the orientation of space. Another way to think about it is in terms of I hat and j hat. Notice that in their starting positions, j hat is to the left of I hat. If, after a transformation, j hat is now on the right of I hat, the orientation of space has been inverted. Whenever this happens, whenever the orientation of space is inverted, the determinant will be negative. The absolute value of the determinant, though, still tells you the factor by which areas have been scaled. For example, the matrix with columns 1, 1, and 2, -1 encodes a transformation that has determinant, I'll just tell you, -3. And what this means is that space gets flipped over and areas are scaled by a factor of 3. So why would this idea of a negative area scaling factor be a natural way to describe orientation flipping? Think about the series of transformations you get by slowly letting I hat get closer and closer to j hat. As I hat gets closer, all of the areas in space are getting squished more and more, meaning the determinant approaches 0. Once I hat lines up perfectly with j hat, the determinant is 0. Then, if I hat continues the way that it was going, doesn't it kind of feel natural for the determinant to keep decreasing into the negative numbers? So that's the understanding of determinants in 2 dimensions. What do you think it should mean for 3 dimensions? It also tells you how much a transformation scales things, but this time, it tells you how much volumes get scaled. Just as in 2 dimensions, where this is easiest to think about by focusing on one particular square with an area 1 and watching only what happens to it, in 3 dimensions, it helps to focus your attention on the specific 1 by 1 by 1 cube whose edges are resting on the basis vectors, I hat, j hat, and k hat. After the transformation, that cube might get warped into some kind of slanty cube. This shape, by the way, has the best name ever, parallelepiped, a name that's made even more delightful when your professor has a nice thick Russian accent. Since this cube starts out with a volume of 1, and the determinant gives the factor by which any volume is scaled, you can think of the determinant simply as being the volume of that parallelepiped that the cube turns.
So, who can explain why do we need, what can we understand using determinant?
Area, volume of shape.
Okay, but what the core idea of determinant? It was the first sentence, his first sentence.
Hello again. So moving forward, I'll be assuming that you have a visual understanding of linear transformations and how they're represented with matrices, the way that I've been talking about in the last few videos. If you think about a couple of these linear transformations, you might notice how some of them seem to stretch space out, while others squish it on in. One thing that turns out to be pretty useful for understanding one of these transformations is to measure exactly how much it stretches or squishes things. More specifically, to measure the factor by which the area of a given region increases or decreases.
But again, what did you say? Галерка. If you have questions, better to ask.
Oh, I have a question. So, he mentioned one case when a determinant is less than 0, so it flips only in one axis, but if we flip 2 axes, so I need to draw an animation. If we flip on x and flip on y, it's minus and minus, and it's positive determinant.
If you flip by more than 360 degrees, then they're going kind of back.
But we can flip not only in one.
What can I say? Just try. You have GeoGebra, you can draw it and try to understand what's going on there. Actually, what do you need to, how can you simulate this? What do you need?
It doesn't matter what.
Let's first of all, let's discuss. How can you simulate it?
Maybe using Python.
Okay, Python. What do you need to find? What do
find the cases of that matrices that can flip twice and find what is the determinant.
But what about tools? What do we need to?
I need to find it.
So you need to know how to find determinant, because otherwise I don't see. This is very nice story to check all the. To make a lot of matrices and check it. What else? You want to understand how it's rotated. So in this case, what do you need to do? You need to take some matrix. How you will check that your matrix is rotated?
You want to understand how
Actually, his question is quite important to understand why we are learning. Actually, what the main goal, one of the goals of our course.
of course of linear algebra. We have the whole year, not only this semester. What does it mean? Okay, determinant. What does it help us to understand? Let's understand some properties of our matrix. That's quite crucial. We have some matrices. What can it be? As I told you, matrix can be linear equations. It can be 2x plus 3y equal to 1, 4x plus 5y equal to 2. So what we are doing there? Actually, we have some matrix or some vector, and we have some transformation. Тима, если сидишь в телефоне, можешь, пожалуйста, просто уйти? Нет, So, what can we do also? And so on. We can represent as a matter, all the stuff. We can represent such manner when we need it. When we are working with least square, when we're trying to solve optimization tasks, when we are solving control theory, how you will have on the second semester, second year. It's widely used in machine learning. And why do we need determinant? Rotation matrix we covered it you covered on the lab or lectures, I know. You have one slide. He also explained you eigenvalues and eigenvalues. He didn't explain, he just said it exists. Yeah? Actually, eigenvalues and eigenvectors help us to understand. We have matrix. We found eigenvalues and eigenvectors for this. It helps us understand what's going on with space or with vector in particular after this transformation. If you take eigenvalue for a rotation matrix, you will find eigenvalue and eigenvector. It will contain complex numbers. Why? Because when we talk about rotation, we cannot actually say that we cannot. Let me see. When we talk about space, we are talking about rotations, and we cannot explain rotation in just pure x and y linear transformation. It's the reason why we have complex number. We are going, let me say, in our new dimension. I know that it's quite. I see your eyes that you are not really understanding what you're doing. But
created a thing to demonstrate.
Let's say finish this. Okay. So the main goal of our course we have matrices. It can consist physics. Represent physics equations, machine learning equations, and we can understand the properties of these matrices. Like in determinant, what we can understand? We can understand that it's linear independent, for instance. Because if determinant equals more than 0, we can understand, okay, this is linear independent. We can use also, you can try to find rank of the Miss matrix, and it also give you some properties. When we do eigenvalues and eigenvectors, we can understand how it will, let's say, affect on our vectors. When we talk about SVD decomposition, we can also understand what's going on with this matrix. To sum up, we are receiving our tools how to explore, investigate what's going on with this matrix. So it's one of the applications in general. So I cannot say we are not going from top down to down. We are going from down to top. So we receiving some tools from the whole year, and after this you can understand how to work with it, some basics. So determinant, it's inverse matrix, matrix rank, and system of linear equations using Cramer's rule. When we are starting when we will learn the Gauss method, Gauss-Jordan method, we will also consider how it can be used.
What is matrix rank?
Matrix rank? How many linear independent vectors do you have? Okay, yeah.
Oh. Okay. have lane can get negative determinant by flipping it on y-axis, but we can also get the negative determinant by flipping it on x-axis. On y, this is y, and the previous was x. So we can flip this and this,
And it will be good.
and it will be positive.
Is actually, it is the same as you just rotated.
Yeah.
Just rotate.
It doesn't matter how you move your x-axis with relative to your old x-axis. It matters how two new axes will be with respect to each other. Like if they have angle less than 180, it will be positive. If they have angle more than 180, it will be negative.
But on the it's correct in 2D case, but in 3D it's,
Yeah, that's what I wondered about. What is going to be, how can this work in 3D space? Because we can change different.
About 3D space, actually there is a right hand.
We have a scalar triple product. Actually, scalar triple product is the, so in 3D scalar triple product or смешанное произведение in Russia equal to determinant equal to this. So
What's about?
again, we have, doesn't matter, CB. We found cross product. So in this case, what does it mean for us? So we have this area.
Remove this parallel pipe.
Yes, parallelogram.
Parallel pipe.
Pipe it will be when we increase the dimension.
And we are talking about 3D space.
No, I'm going how we are receiving triple C, I mean parallel pipe.
Okay.
We are having CB. We found area. After this, what we are receiving also? The vector. So it will be like this. We are making this vector and A, and this vector will be dot product because it's similarity and we have projection. Actually, it's about projection. And it's the reason why we are receiving, let's say, the volume of this parallel pipe. So we have area, we add new vector. That's it.
So the result is projection of A to the
BC, we receive vector.
Huh? I can see.
BC, we receive vector. These two vectors, we want to find similarity. Actually, we want to, how to say, project them. For A, we receive.
Project where?
When you multiply B by C, you get vector perpendicular.
Because you have
to
A
this plane.
and you have B.
And then you find similarity.
It's not this. They are not similar in general case.
What do you mean similar?
What the property of dot product?
The
Find the similarity between two vectors.
Okay.
And we actually it's about projection. If we just project in this vector. Let's discuss how to calculate determinant. In general, we have this equation, and I will explain why it's important to understand how it works. Who knows these septish arrows? Or also you have triangular part. What? First of all, let's derive this equation using the general formula. So AB, CD. We know that determinant of this matrix should be AD minus BC. Now let's derive it using original equation. In common case, I want to take this row minus 1. It's first column, first row, 1 plus 1. Multiply on this A. And we need to find determinant of the smaller m. I forgot how it's called in Russian and English, but actually it's a determinant of smaller determinant. So in our case it will be determinant of D, it's equal to D.
plus. I'm taking, so how I receive this? I close the column and the row will be how to say it, for the point which I took. But after this I took B. To be minus 2 plus 1 because first row, second column, apply on B and multiply on C. And it should be the same. Why do we need it? How we receive this one? Actually, in the common practice, we used to do it in that you just close, you are choosing this row, and we receive minus there because it will be second first, and it's the reason why there's the minus.
Does this formula work for an arbitrary row?
For what?
For what?
For an arbitrary row. Like, can we do this with not first but second row?
And I want to say yes. It's a reason, and we can play the game.
Can we come with matrices?
Prove that for any matrix.
Let's choose this. I will choose.
Are these four numbers 2 or 1?
3.
So if you know how to solve determinant, solve it right now. Let's check who will be faster. So I will choose this one. So guys, if you know, let's do it.
So what? Ah, is
You
it
need to find
1, 0,
determinant.
and 90?
Yes.
I thought it's 1090.
No. So we take this one.
I think it's minus 4. We have different answers.
Minus 600.
What again?
There should be minus, yes.
Minus
1,
600.
0, 90.
I have the same answer.
You have the same answer? I have a different answer.
So did you receive the answer?
Yeah. The same answer.
The same.
So
So, yes.
probably if you solve the common matter, you have to solve 3 big these guys, or you have a lot of problems when you write it in common manner when you use arrows. In my case, I can choose any row or column. In this case, I see 2 zeros, and I choose this column as my column for this equation. So actually, 0. So what I need to do? Doing this 0 minus 1, 2 plus 1. It will be 2, 3, 7, 8. Plus this one. Plus it will be 3, 2. One 90, 2, 3. It might help you a lot during the exam, because I'm not spending a lot of time to calculate. I just know that it's equal to 0, this is equal to 0, and I calculate only 1, 2 by 2. I receive the complexity, hence I have lesser chance to make a mistake. Did you get what I done? You can choose any column row which you need to go. We used to go though in classical way. You are going from this to this, so it will be 1, 1, 1, 3, 0, 8 minus 0, 2, 3, 7, 8, yes, plus 90, 2, 1, 7, 0. But I can choose any column or row and I go just for this. But in this case I need to be aware of making mistake with sign. And how I receive them.
Is determinant of multiplying two matrices is the same as multiplication of determinants of two matrices?
I don't remember this property. Actually, just property. Open the Wikipedia and I hope you find this. You can check.
Actually, I think yes. We recursion to like recursion around.
It means I can choose any column or any row.
Yes. And when you're going through this, yes, you can.
We have more than 3 dimensional.
No problem. Actually, you're doing the same. Actually, on exam you will have 4x4, if not mistaken, dimension.
And calculate determinant of
Yes. And if you know this method, it can widely help you, because if you choose the correct way, you won't have a lot of zeros, or you will have a lot of zeros, and you don't need to calculate determinant for this point.
Can you show determinant for 4x4?
I want vision.
Okay, for instance, this one.
Fourth column.
I will choose this one because it will be easier. In this case, okay, 4 minus 1, 4, 1.
What?
Ah. 5, 6, 0, 7, 7, 9. Plus 0, blah 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 blah, and minus. In this case, how you calculate this? Again, you choose a column row and solving this.
It is also determinant of this matrix.
Yes, you need to find determinant for this, it will be value, you put it there. And if you're choosing, yes, you can just solve it in a straightforward way like this, but good luck.
I have two questions. How do you choose the 3x3 matrices?
When I choose the column row,
The last one?
I choose this column. I take the first component. I need to close the intersection between this and add other matrix as other values as it is, like this. I added. After this, for instance, I go to 0. And then you write 1, 2, 3, 7, 7, 9, 3, 2, 5, 7.
Ah.
Stepping. Again, we have column and row. According to equation I plus G.
Do you have
But if we will take, for example, third
x
column,
Yes.
equals
xy?
such
Yes.
in center of matrix, we just
We just taking, yes, for instance, we choose like this, in center. And yes, we will take 1, 2, 3, 4. So, this sector stuff, blah, blah, blah. Okay, you may ask the question. Let's check one property. One guy should solve it in such manner, another we write as the columns. So it's written as rows, each vector. Tim, could you solve it on whiteboard using columns or columns? Yes, not rows.
What?
Go solve it as it is. Solve this determinant as it is. Go, go, go. Go, go, go.
Is anyway?
No, yes, you can use any way. You need to solve this one. So you already did the column.
columns.
You have vector A, vector B, or vector C.
I don't know how to calculate triple scalar.
It's not triple scale. It's just determinant 3 by 3.
Whoa.
You don't need to sequence, just solve the determinant.
You said I should solve it.
You can say that for triple scalar product is just a determinant of 3 by 3 matrix. Your goal to solve it, but you wrote it in vector. I mean, as a columns, not as a row.
That's ugly. Why do we put them as row vectors?
Because.
Because what? Because. And yeah, may I ask you about the?
No. You're writing as a column.
-1, -1, 5. Вот ты пишешь как колонку вектора. Я хочу, чтобы ты решил эту же задачу вот так. Найди детерминант мне 3 на 3, только решила, чтобы у тебя вектор А, Б и С был так.
Я опять не ничего.
Напиши мне не как
Transposition.
Транспоз посчитай.
What's the geometrical sense of scalar triple product? It's a projection of A to where?
It's volume. Volume of parallel pipette. What?
Okay. Is there any sense but geometrical?
А какой тебе еще сенс?
Да, какой тебе сенс нужен? Сенс вот тебе может быть. Думал. Давайте убедимся, что он одинаковый.
Ну, он почти правильно написал.
А что неправильно?
Ну,
Хочешь подсказать?
нет.
Давай.
Что не так? Давай. Дерзай. Все в твоих руках.
Не, все верно.
Ой. Как же.
Ох уж эти сарказмометры попахивают. Ладно, пока вы там деретесь, я проверю ваши. What's your answer?
What is the four
Where is answer?
There is no answer.
No, I'm using these two ways.
Yeah, okay.
And what's the answer is?
No, I'm using
Can you find the answer?
Замедленная реакция. Just write the number.
He's solving.
That's correct. Just write the number. Good. Well done.
Okay.
Well done, yes, 0 and...
It sounded like a great. Well done, 0.
what to solve.
We are checking that...
Answer is not here.
We are checking that determinant for matrix and transpose matrix will be the same. You saw that he received 0.
No, he didn't calculate. He did. Sorry. Are you doing it for the first row? Are you doing it for the first row? Sorry.
First column.
Sorry. Yes. Right.
Minus plus Hooray. So, you may see he also received 0. Okay. No, it's okay. Minus 7, minus,
-3
minus.
plus 10.
Minus, 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 minus. Okay.
Where is
Oh.
You forgot.
Probably this was the sign of the very first
Кстати,
sign.
молодец.
Я прочитал просто. You forgot extra minus.
Тоже будет пофиг.
Just write plus.
Все равно поменяется знак, да, потому что у тебя же и же появится.
Second minus.
square is minus
У тебя же вектора, у тебя как раз произойдет смена.
You see? You have two minuses, a minus one, and then.
У тебя же базис, когда у тебя может быть левосторонний базис, правосторонний.
You have minus 1 power 2.
Но это же должно быть
Okay?
логично. Когда ты скилишь пространство.
Так ты можешь проверить, ты просто.
Я щас-
Нет, я понял, я просто ты типа считаешь.
Какие ты проверишь?
Как ты просто берешь и считаешь детерминант так и так. Умножь
С
матрицу,
рандомными
потом.
циферками это может получиться так, что тебе просто повезло.
Ну.
Вроде бы это проверять, а я не знаю MATLAB, поэтому надо это искать.
This is minus 1.
Okay.
This is minus.
So guys, let's continue because we have more interesting tasks. Guys, галерка. So I hope we won't do it because we already done the similar task. About this. Верно? Okay. So we can solve it as we did it on the previous two classes ago.
Yes.
But also we can do it using this way.
Why it's Russian?
Because actually
Вот профиль.
no, the how to say who will explain in the next class how it works.
Лично.
Why, for instance, we have 1, 1, 1 there, and so on. I will give some cookies for you.
Cookies?
Yes.
Интернет cookies?
No, real cookies.
Cookies.
Some switches. Yes. You will have a slide. Why do you making photos of this?
I have one question.
Yes.
Which cookies?
If you
Why do we have
prepare,
ones there?
if you prepare that, you can do it on next class. Yes.
We have matrix with the 3, 4, 3, 4, 5. It has determinant or not?
3, 4, 5, what?
3, 4, 5. What?
No, 4. 4 columns.
You can find the term. You can find determinant only for square matrix. Okay.
What is the determinant of matrix 1 by 1?
Just matrix. Actually, we did it in 2 by 2. You're also receiving.
1 by 1.
Yes.
Just this guy.
When, according to equation. I forgot how to call this M. It's minor, if not mistaken. Yes, minor. Mhm. So, according to the equation, we are doing almost the same.
1 by 1, not 2 by 2.
He will show you.
I'm
Wait
showing
for
you.
it, yes.
Because in this case, what is it? Determinant of 2 by 2. Do you agree?
Yes.
When we are solving like this, it will be 1 minus 1, 1 plus 1, determinant of 4. Determinant of 4 equal to 4.
Oppa.
Because it's a recursive equation. You're going down, down, down. Down, down,
Is the
down.
determinant of 0 by 0 matrix defined?
I'm not mathematician. For our life, I don't need it. Okay. Who can solve this task? Who did it?
I think I can.
You also. Okay, I need more volunteers.
There is somebody.
You also can.
We gonna try.
Let's do it.
I want to try.
No. You already were on the was near to the whiteboard. Держи. So first of all, what can we do? What can we do? Yes.
Find the matrix product.
Okay, where multiply them? Let's do it.
Same.
Okay, we have answer.
Huh? Whoa! You can define matrices with variables.
Ooh.
Is it not whoa?
If you want to check something, you can use SymPy in in Python. SymPy. NumPy for matrix work and SymPy for symbolic.
Okay. Simple. I heard as one guy called NumPy as NumPy.
It's okay. How it will be? Adobe Photoshop? Or is it correct?
Adobe Photoshop. Yeah.
It's not incorrect. Adobe. You need to go.
Okay.
Yes. Like Xerox, no Xerox, because it's Xenogears. X is not X in English in such cases.
Wait, what? Again.
Xerox, Xerox. It's Xerox in English.
And
Which
what's the
number is correct answer?
what's the original country which produced it?
US, if not mistaken. It's just how to say. It's a pronunciation. Like Xenogears, the game.
Yeah,
Xena, Королева воинов. Written in English, Xena. I can show.
Xenon может быть.
Я честно делаю, что на полном энтузиазме.
Делай, умница. Делай, ты считывай.
Потом посмотрим наверх посмотрим.
Ксена.
Гена.
So just to exceed your horizons, you know?
It's like M&M's.
Which answer is correct?
Yes, sir.
Вышел бы.
But
Mm.
another task.
What do you mean?
We should find determinant.
I
Cannot not do this.
Okay, actually you can just write -2. Последней колоночке -2.
У меня тут неправильно.
Да, ты просто переверни их.
Там же минус.
Вот, минус, да. -2. Okay, what we are doing next? Largest possible solution. Guys, what can you think? So, first of all, we need to find determinant.
Yeah.
Could you write the determinant?
So,
Ты слишком умный. Это есть другой вариант. Че?
Он тоже знает. Нам производные проще делать, чем вот это все. Ну, можно что-то квадрат выделить.
Все.
Просто производным здесь все.
Вы тут все просто д'Артаньяны. Из школьной программы вы должны знать, как по-другому решить эту задачу.
У тебя есть
So-
реши на параболу, если она.
We can draw just parabola.
Yes. So the first case is understand that it's
Минус b.
parabola which have like this, and because of this you know the equation and you can find this point.
Yes.
I think so.
Достаточно было?
So Vic, what can you say about this? So you want to how do you want to solve this task? Okay. Vertex, окей.
That's understand.
Еще раз.
What's that? 10?
I don't remember. Probably 10 for x and y equal 120. Yeah, so okay, yes. So guys, again to sum up, we can solve this task using two manners. One of them when you attack. Давайте потише. Коля. We can solve this task using two manners. First, as Vika proposed, we know that its parabola looks like this. It's the case that max value should be on upper part. We can find this point, it will be max value, and after this, hooray, we solve this task. If we know the equation of this point. If you're a dummy, or you're, I mean not dummy actually, you're forgetting all these equations, you can know, but you are not learning this yet during the mathematician analysis, you can take the derivative of this equation. And after this, you're equal to 0, and you will find the max value. Yes, critical point, blah blah blah, yes. Okay, thanks. Yes. Firstly, yes, guys, you asked me so about wolf. Yes, I prepared. First of all, that the statement, the wolf is weaker than. Yes, and I show yes. First of all, okay, but also I added a video. Okay. Looks like you. So, if I'm calling this place as a circus, as you may see, even wolves can participate in it. So, okay, the last question which we're not covering: who tried to solve the home task? Did you have any problem? At least you should solve it next time. But
have questions.
So, for which task?
4 and probably 5.
Okay, all of you have such problem.
Yes.
And where it is? It's not this. Where is my?
Or 5 and probably 4. Something around there.
Moodle.
Oh, you have photo.
Okay, the fifth task.
This one.
I give you. What was the main problem?
What was the main problem? Oh, should we start with 5? The main problem was I didn't know how to convert things from one basis to another. Now I know, so... wait, that's not... Yeah, still, because they are not defined as coordinates, but as angles and
Guys,
lengths.
okay, guys, read the fifth task. I will give you not a hint, maybe say, but...
Solution.
The previous group asked me this task, how to solve this task. I didn't solve it during the class, but I mean, when I had a lunch, I understood how to solve this. So, first of all, we need to understand what's going on there. Okay, we have three vectors and we have their length. A1, A2, A3. So we have one equation, one equation, one equation. what we also have? We have some angles. What can we do with them? Dot product.
Oh.
So angle 1 is
Dot product divided by length.
also we have some variables, we have equation. So somewhere we have 3 equations. I mean, I hope you got it. The equation, blah blah. We have 7 equations. What we need to find? We need to find the volume of parallelepiped, blah blah blah.
Which is
When we are talking about, we need to understand that in this case, we cannot say that our determinant of parallelepiped will be equal to 1, 2 minus 1.
yeah, because it will be changed.
It's typo. It seems it's typo. It's not 14. It's typo. I think so.
We should separately calculate the volume of it
It's wrong. Why?
because
Our
our
negative.
Wrong basis.
What again?
Wrong basis.
It's yes.
Here we
so
can
in this
have
case,
basis
we
one.
add E1, E2, E3. So how many variables do we have there?
3.
Are you sure? It's coordinate x, y, and z.
Mm-hmm.
Why? 9. And we may say, okay, we have 3 equations there, 3 equations there, but we need to find 3 more. How to solve this task?
Find 3
Probably
more.
we should calculate first the volume in our 111 coordinates.
We did it. Okay,
And
we found.
then we should somehow calculate the determinant of only the.
We don't have problems.
Yes. So we have 9. We have Hawaiian. How to say? There are 9 variables.
Это вообще не 2 разных задания?
Нет.
Так можно же, зная длины, и просто углы найти сверху.
Что найти?
Ну, нам даны длины и углы между векторами. Мы можем найти сразу отсюда подъем. Зачем нам вообще то, что снизу дано?
Ты же хочешь найти через
You know.
3 базис.
You know the volume, so you can say. I think how to explain this.
You had bases 100, 010, and 001.
Yes, in
And
original
then
case you have basis, but you have another basis.
You have changed bases to E1, E2, E3. And you need to calculate the volume of the old parallelepiped in the new basis.
So the question: can you just how to find this determinant and that's it? Answer
You
is
can
no.
find volume previously and then multiply it by that determinant of that.
Yeah, that's what I wanted to do, but I don't understand how to retrieve the determinant of the transformation.
Yeah, is it correct?
Like by the what?
Transform
we
basis
want-
and it will be.
Actually, you can say that this is equal to indemnity matrix because it will be one. Some determinant. I understood what I talked about, but it won't give you needed equations. You, in spite of it, you have 9 variables. You don't know the vector. You don't know these vectors.
We know that square of first coordinate plus second plus third will be equal to 1, then about the second vector is the same, the third is the
Okay,
same.
we have one equation.
We have additional 3 equations.
We have 3 equations there. 3 equations there.
And additional 3 equations about x, y, z for each vector.
Could you write?
X squared plus y squared plus z squared.
What x? What is mean x? A1.
Okay.
A1 x squared.
Yeah.
It is.
No. X1 squared plus y1 squared plus.
But they are not variables. We know them.
We know them.
The x1 equals to -1, y1 equals to 0.
У нас
Just
разные
one
понятия
was-
x по поводу вот у тех векторов, которые и 1, и 2, и 3.
Да.
Вот эти базисные векторы, мы у них не знаем x, y, z.
Да.
Но
у
вот
всех.
мы их можем найти.
Вот ты можешь найти x, y, z у этого, x, y, z у этого. Если мы это найдем, мы решили задачу.
Ну,
да.
я и говорю,
так
что
вот,
это
скажи
можно
мне
найти.
еще
Так
вот.
я вам говорю,
Можешь написать все, я посмотрю. Вот сейчас в тетрадке. Напиши все 9 камней. Не, просто если ты понимаешь, напиши без шуток. Может, нашел какой-то другой способ. Okay. But for others, I will explain how we can solve it. I mean, we have generally 6 equations. We need 3 more. This is our basis. It is. We know the length of each basis. So let's assume that it's 3 our vectors. We know their length. And we know how they are positioned according to each other. Because we know angle between each of them. Vectors are frameless. But we don't know the coordinates. So actually, I'll receive this parallel Python. So what can I do? I can take one basis, for instance, x, and say that E1 equal to E1, 0, 0. So now I have this needed 3 variables because I already proposed this 1, 0, 0.
Yeah.
So I solved this task.
Wow. Nice.
I am saying that E1 is equal to, I can just propose it. Ну, типа, это поставить statement.
Let.
So that's it. You're just saying that your E1 equal to this. That's it, I solve this task because I have 6 equations, 6 variables. Oh, I mean, I have this, will be there. So I have from the 6 variables, 6 equations. And I solve this task.
And,
Again, how it works, because when I talk about basis related to some coordinate frame. But right now, it can, so this structure can be a fly and I can put it there or whatever. I just put it in our EGK on our common, Cartesian space. And that's it, I solve this task.
regarding the fourth exercise, should we judge about vectors complementarness by determinant being 0?
I need to read the task, I don't know.